We are starting off with some definitions to avoid any confusion on the terms that are frequently used in machine learning. So let's review some basic definitions. Artificial intelligence has a very general scope. It includes a lot of algorithms and general solutions. As per the definition in Wikipedia, it is the study of intelligent agents, that is, any device that perceives its environment and takes action that maximize its chance of successfully achieving its goals. As we can see, the definition is very general indeed. It can include many entities, uh, classical software development, bunch of if-else statements, etc. can be a part of artificial intelligence. Machine learning is a subset, or you can say a subfield of artificial intelligence. Here also, we perform some specific tasks, but we do not explicitly program. We take the help of existing data to learn how to automate a specific task. Cited here is a famous quotation from Arthur Samuel in quotes, "How can computers learn to solve problems without being explicitly programmed?" With these lectures on machine learning, hopefully, we will be able to answer this question. For now, let's just remember that artificial intelligence is very general and machine learning is a subfield where we use data to solve tasks. Since most part of machine learning are not explicitly programmed, it can be challenging in comparison to software engineering. But we will talk about it in details, the problem faced and how to handle such challenges. It is advisable not to use the term artificial intelligence and machine learning interchangeably, primarily due to the reasons that we just talked about. Now let's try to understand what constitutes machine learning. So, machine learning is divided in two parts: classical machine learning, also known as shallow machine learning, and representation learning. In classical machine learning, we as engineers define features from the raw data. By defining features, we represent our raw data to be fed as input to a machine learning model. Neither does the classical machine learning model accepts raw data as input, nor it has access to it. The model only relies on the input features that are a fixed representation of the raw data. Contrary to classical learning, representation learning models can learn from the raw data. In representation learning, the model learns to encode or generate its own features from the raw data and then further learns on those generated features. We can see that in representation learning, the model has much more work to do in comparison to classical machine learning. We can also see that the human effort to generate features that can represent the raw data, which has to be manually performed in case of classical machine learning, is not there in representation learning. But for sure, this advantage in representation learning comes with a cost that we will review later in the lectures. Deep learning, which is a subset of representation learning, is quite famous for its use of neural networks to encode features on its own from the raw data and to utilize these self-generated features to perform various tasks. As I mentioned, classical machine learning is also called shallow machine learning, which actually is a pun used to derive a contrast from deep learning. Now let's try to have an understanding of the vocabulary and some of the basic terms that are frequently used in machine learning. So, an example in machine learning is an object or a person. An example is something that we want to give to our model. Usually, one example is one row in a dataset. In machine learning, a feature is an input variable to a machine learning model. It is represented usually as a column or as a one-dimensional array. A feature is a characteristic of our example. Later in the lecture, we will talk about it in detail and some examples as well. A label is supposedly the output variable which we get from the model. It is the answer or the result that we want our machine learning model to produce. Usually, it is represented as a column in a dataset. And everything constitutes to create a dataset. A dataset is a set of examples. It is represented as a matrix or in mathematics as a two-dimensional array. In a dataset, we have examples that follow each other in rows and features that are represented in columns. Similar to a feature, label is also represented as a column. But in contrast, there are usually multiple features for a single label, hence one column in the dataset. Here are the link to the glossary in the Google developers website. It's really useful. And if we have some doubt about a specific term or vocabulary in general, so please feel free to refer it. Now let's talk about the type of task that we can perform via machine learning.